Hey, can I get your number? Only if it's my mass or proton number. Boom! Hey everybody, welcome back to Seneca Prep. I'm Jono. Today I'm going to be talking through mass numbers, proton numbers, and isotopes. You're welcome. Let's dive in because we've got lots to cover, and I want to be concise and didactic. That's my two adjectives for today. Let's go. So, an atom can be defined by its mass and its proton number, and so much more. So much more. But today, just mass number and proton number. So, what's the mass number? Well, the mass number of an atom is the number of protons plus the number of neutrons. You hear that? It's protons plus neutrons. And we give this as the symbol A for amazing or mass number. The proton number of an atom is the number of protons in the nucleus. Remember, the nucleus is in the center of an atom. That's covered in a previous episode, so make sure you check that out to get up to speed. So those are the two key numbers that you need to know. It's the mass number and the proton number. And the proton number of atoms in the nucleus, mass number, the number of protons plus the number of neutrons. Now, if we remember, the mass number is often given by the symbol A and the proton number is given by the symbol Z. Such fun. Okay, next we're going to be going over ion formation. We're going to get charged today. So an atom can have electrons added or removed. This generates ions. Positive ions. A positive ion has more protons than electrons. Remember, this is because protons have a positive charge and electrons have a negative charge. So a positive ion is going to have more protons than electrons. So how do we generate positive ions? Well, we can do it by removing electrons from a neutral atom. And positive ions, we call them cations. Cations. Think about cats, they're great, cations. And this term comes from electrochemistry because cations are attracted to the cathode. So cations go to the cathode. So the cathode is negative because the positive cations go to it. Boom. We love it. How do we make negative ions? Well, negative ions have fewer protons than electrons, so it's the opposite to positive ions. And if you remember, to make positive ions, we lost electrons. So to make negative ions, we add electrons. And we often call the negative ions anions. So negative ion, anion, positive ion, cation. Remember those key terms. I'd put those on a post-it and stick them up in the mirror so when you're brushing your teeth, you remember those definitions. Because they can be confusing, and they come up on those like weird multiple choice questions at the start of the SAT subject test a lot. So you're welcome for the advice. Seneca Prep. Calculating charge. So ion charge is the number of protons minus the number of electrons. Groundbreaking. Overall charge is the overall charge of a chemical substance. Of any chemical substance will be zero. What? So cations will always be accompanied by anions in solid or solution. There we go. Isn't that fun? So let's go over some key facts about cations before we move on. So they are always accompanied by anions, they're positive ions, and they have more protons than electrons. Those are key things about cations. So do you remember how ions are formed? So it's by adding or removing electrons from atoms. So that is how we make ions. All about moving electrons. Remember, electrons are in orbitals and are in shells outside of the nucleus, so it's easier to move electrons than it is protons. Protons then nicely in that little center in the nucleus. So now we're going to be talking over isotopes. So atoms are defined as having a particular proton number, but plot twist, this definition says nothing about the mass number. So isotopes are atoms of the same element, yes, the same element, that have the same proton number, but a different neutron number. This means atoms have different number of neutrons. So basically, key thing with isotopes, they're atoms of an element that have the same amount of protons, but a different amount of neutrons. So important examples of different isotopes are the radioactive 40 potassium and the stable 39 potassium isotopes. And the 40 potassium is the reason bananas are slightly radioactive. Bet you're thinking about your oatmeal differently now. The superscripted number, so we write this as like superscript 40 and then K for potassium. And it's that superscript number indicates the mass number. So 40K is potassium with a mass number of 40, 39K is potassium with a mass number of 39. Effect on chemistry. What is the effect on chemistry? Well, chemistry is largely about electrostatic interactions between nuclei and electrons. Neutrons, honey, they're neutral. They haven't got any charge. So changing the mass number of a species rarely affects its chemistry. This means that it's very difficult to chemically distinguish isotopes. Gosh damn. So it's really hard to distinguish between different isotopes. So do you remember the charge from a neutron? It's 0. Neutrons don't have any charge. They are neutral. So isotopes have a different number of neutrons, and different isotopes have very similar chemistry to each other. So isotopes have very similar chemistry. So do you remember the symbol for mass number? That was an A, and proton number is often given with a Z. So a sodium Na plus atom forms a large ion. This ion is formed by losing one electron. It forms a positive ion. So sodium forms a positive ion by losing one electron. Let's recap isotopes one more time. Isotopes have the same proton number but a different mass number. This means they've got the same amount of protons but a different number of neutrons. Boom, isotopes done. Done. So same proton number but a different mass number. That's all you take away from this episode. I'm a happy guy. So mass number is number of neutrons plus the number of protons. Amazing, groundbreaking, revolutionary, never be the same again. Boom, we did it. Amazing. Hope you enjoyed this episode. Thank you very much for checking it out, and I will catch you on the next one. I've been Jono from Seneca Prep. Good luck with all your test prep. Nailing it. Well done for being proactive in your learning and checking out this episode. Appreciate it. Bye.